Good morning, dear students. I am Dr. Bhatri Srinivas, Professor of Chemistry. Today we are going to start Unit 2 revision, that is water and its treatment. So already we have discussed the hot water, types of hot waters, and treatment, internal treatment of hot water and external treatment of hot water. So today we have to discuss external treatment of hot water. So why we need the external treatment of hot water? Why we need the purification? The purification water is necessary for human consumption and construction of buildings, and soft water for industrial use. For example, if we use the construction, a civil engineer can use this hot water. What happened? After some times, the buildings may collapse or bridges will collapse because the salt is more in the water. The hot water containing the more number of salts. So that is the reason it is necessary whether it is a hot water or a soft water. So that is, if hot water, we have to purify that hot water. Or any mechanical engineer. So if they are using the hot water in industry, so what happens? That all boilers or engineering materials may getting rust if you use the hot water. So that is the reason we need the external purification of water. The purification is necessary. So now today our class is that external treatment of hot water, means softening of the, means purify the water. So softening of hot water can be done by three methods. One is a lime soda process, another one is zeolite methods, and the third one is ion exchange resin method. So among these three, the ion exchange resin method is a very important method, and according to our JEE syllabus, so ion exchange resin method for purification of hot water. So we have to read and write, and what type of questions will come in this ion exchange resin method. What type of question? The first question is, explain the ion exchange method for purification of hot water, and explain the demineralization of hot water by using of resins. And third question is, what is resin? What is a resin? And explain in detail. And fourth question is, what is regeneration for exhausted resin? Exhausted resin. How can you regenerate? So these are the four questions will may ask in the university examination. So let us discuss the ion exchange method. First question is, we have to know the resin. So what is meant by resin? A resin is an organic polymer. A resin is an organic polymer, cross-linked organic polymer. It is a cross-linked polymer having microporous structure. Microporous structure. So how the microporous structure? So this is the microporous structure. Microporous structure. So microporous structure. See here, first of all, resin. It's in a cross-linked like this. The blue colors. This is the blue color. Is a cross-linked. This is in a polymer, a porous structure, and cross-linked organic polymers having the functional groups, the basic functional group and acidic functional group. Basic functional group and acidic functional group. So resin is a organic cross-linked polymer and having the porous structure, micropores, and it has two functional groups. One is the acidic functional group, another one is the basic functional groups. Mean when we have to use this resin, the two types of resins are required for the purification of water. The purification of water, how many types are required? Two types of resins required. One is the basic resin, another one is the acidic resin. The basic reaction is mean what? The basic nitrogenous content. Acidic reaction mean acid group, that is H plus ion, release of H plus, and basic mean release of OH minus. So these two types of resins can be used in the purification of hot water by ion exchange resin method. Okay. Now the resin structure. So two types of resin. One is the acidic resin, another one is the basic resin. So this is the acidic resin containing the functional group, acidic functional group. What is that acidic functional group? That is the sulfonic acid. Sulfonic acid functional group, SO3H. So what happened to this SO3H? When SO3H, the acid functional group, when react with the metals like sodium, potassium, calcium, so the sodium salt of acid, for example, this structure here, the sodium salt of acid, this is the sodium salt, mean CH2COO Na, acid group, like SO3Na plus, mean this resin when treated with the hot water containing the sodium or potassium or calcium or magnesium, that when metals react with the acid to form the, and when the base, this is the basic structure, microporous resin. For example, this is the trialkyl group, CH3CH2 trialkyl. But here written the one group is the ethyl alcohol and one is the methyl and CH3. But the nitrogen compound N plus. It is a basic functional group and OH. Mean here this compound when react with the salts containing the chlorides, anions, like sulfates, the replacement of sulfate, and so mean here the N plus and Cl, N plus and Cl. means CH3Cl. N plus, this is the, if trialkyl is a group is there, that Cl minus is replaced. Mean anions. The anion group is the hot water present salts like sodium chloride. Sodium is taken the acidic group and chloride is taken by the basic group. So these are the two structures. These are the two resins, basic resin and acidic resin. So the structure of resins are important for. So when they are asking the what is the resin mean, the definition as well as the structure. This is the most important. This is the most important resin we can write in the examination. So otherwise, this is the one cation resin and anion resin. So cation resin is an acidic function. The acidic resin is also called as what? Cation exchange resin. And anion, the basic functional group containing is the anion exchange resin. The two types of resin is what? The cation exchange resin, anion exchange resin. The cation exchange resin is an acidic functional group and anion exchange resin is the basic functional group. So these are the two types. So generally we can write the cation exchange resin is RH plus. RH plus, that is the cation exchange resin. R is the resin structure and H plus is the indicate the acid group. And in the case of anion exchange resin, we can write ROH. Mean R is indicated for the whole structure and OH is indicated for the anion exchange. This is the structure. The first question means it is what? The resin. Now the process. So what is the process? In this process we have to know the schematic diagram of the ion exchange resin. It's the most important. What is that? Schematic diagram. The schematic diagram. So what is the schematic diagram? So this is the demineralization process by ion exchange. This is the schematic diagram. So we have to practice and write the neatly draw it. So in this we have to remind, so the three cylinders, first of all labeling. First draw it and label it. So what are the label? So draw the three cylinders. One is the anion, another one is the cation, and the third one is the degasifier. So this cylinder, the first cylinder is right that cation exchange cylinder, and this is the anion exchange cylinder, and this cylinder is the degasifier. The degasifier is surrounded by the steam jacket. Mean that steam jacket, because we have to produce the steam finally. And the first cylinder filled by the some gravels, and above the gravels we have to use the acidic functional group, mean the cation resin is filled in that cylinder. And in the second cylinder we have to use the anion exchange resin. This is the anion exchange resin, and the bottom contains the gravels. So one is the cation exchange resin cylinder, another one is the anion exchange resin, and third one is the degasifier. These three we have to draw it. And the pipes, and one is for the acids for regeneration purpose, and another one is this is the alkali for the regeneration of anion exchange resin. So these are the labelings. First draw the diagram and label it well. Now write the process. What is process? The process is made. So explain the ion exchange resin mean you have to draw it well and label it well and write the process. The process mean what happened to process? Here when the impure water, mean hard water, the hard water pass through the cation exchange. The hard water, mean impure water, passes into the anion cation exchange resin. The cations, we know that what are H plus. The H is replaced by the salts like magnesium or calcium. Mean RCA, RNG will form. And then from this, the water containing, mean the resin absorb the all cations present in the hot water. And the equal amount of H plus ion released in this water. Now from the impure water coming like this and passing through the resin, and here the cation is absorbed. If magnesium chloride is present, the magnesium absorbed and chlorides remaining present, and the chlorides and H plus ions, and this water mean acidic water. Why it is called the acidic water? Because the chlorides are present and equal amount of H plus ions resin, mean acidic water. This water and slowly move into the another cylinder, that cylinder containing the anion exchange resin. That anion exchange resin mean it absorbs the anions. Anions mean when this anion, mean the chlorides are present in the anion, the resin is absorbed. Mean that odd water, impure water, for example, magnesium chloride is present, magnesium absorbed by the cation and chloride is absorbed by the anion. Now that completely salt absorbed by this resin. Now only that equal amount of H plus ion released by cation and equal amount of OH plus ions are released by the anion. Mean H plus and OH minus combine together to form the water molecule. And this water molecule slowly move into the DEGASIFIER cylinder. In this, the bacterials are there, the carbon dioxide is there. When we have to eat and pumping with the steam, that steam at higher temperature, the gases are removed. The gases were removed. And the bacterial infection also at high temperature, if you boil it, that bacteria also kills in this stage. And we will get the demineralized water and softening water. This water can be used by the industrial purpose or human consumption or construction of buildings. We can use it. Okay, this is the process. And write this process and write the chemical equations. So what are the chemical equations? This is the most important of the chemical equations. So the chemical equation, we know that RH plus is the resin, when the odd water containing the calcium chloride and magnesium chloride, mean the calcium is the cation and the cation resin absorb the Ca plus 2, mean R2Ca plus 2, and equivalent of H plus ion released. Whether if you are to presence of calcium is like that the first equation, and if the presence of magnesium chloride, the second equation we have to write. If you can write both the equation, it's very good for this cation absorption by the cation exchange resin. And anions, the absorption of anions. If the calcium chloride present, or calcium sulfate is present, or magnesium chloride is present, or magnesium sulfate is present, the anion exchange, ROH, that anion is absorbed by the sulfate. Means sulfates or chloride absorbed by the anion exchange resin. And equal amount of OH minus is released. Mean in the first case, in the first reaction, the H plus ions were released, and here the OH minus released here. and both H plus ions and OH minus ions combine together to form the water molecule. So these are the some chemical reactions involved in the purification of water, or softening of hot water. So these are the very very important. And finally, that the fourth question is the regeneration of ion exchange resin. How can you regenerate? So once we have to use the resin, if the absorption of the calcium and chlorides, the resin will not work same. So we have to regenerate, mean the exhausted resin we have to regenerate it. So regenerated by from this one. So this is the exhausted one, mean the resin is completely the metal resin. Here the anide, chloride or sulfate resins. Now we have to use this one. So this one we have to regenerate. So how can you regenerate this one? In this, so from this cylinder, the small cylinder attached with the resin cylinder, so we have to fill the dilute acids, either dilute sulfuric acid or dilute HCl we have to use in this. So that the dilute acids so slowly coming to this resin. The resin containing the calcium or magnesium, and when treated with the HCl, that the calcium is react with the HCl, mean the chlorides are taken, and salt, calcium chloride and calcium magnesium chloride is formed. When washing this with the water, the salts are dissolved in that. So number of times you have to wash it and washing out, and you have to completely drain out from the washed one. Mean it is purified, mean it is regenerated, mean remaining RH plus ion. The RH plus ion, mean HCl, mean the resin containing the RCa, and Ca is taken by the Cl minus, and calcium chloride is removed, and H plus is react with the resin and RH plus, mean it is regenerated. Like that anions also, here that resin chlorides or resin sulfides are there. If you have to use the dilute alkali, dilute sodium hydroxide for regeneration, so in the cylinder slowly you have to pump into this one. That here the sodium hydroxide is there. The sodium react with the chlorides, resins. It takes the sodium chloride formation takes place, or sodium sulfate formation takes place. And the OH is react with the resin, and ROH mean the regenerated this resin, and we have to wash this one. So these are the washings. So number of 3 to 4 times we have to use the pure water, then regenerated. And what are the chemical equations involved for regeneration? This is very very important. You have to write the chemical reactions are more important. So regeneration of ion exchange resin, we have to write the cation exchange resin. So when the cation containing the R2Ca2, that is a cation resin, when react with the dilute HCl, the dilute HCl containing the H plus ion, from the H2SO4 or HCl. So to form the RH plus, 2 moles of RH plus, so this is the reaction. And calcium is reactive with the calcium react with the Cl minus or sulfate minus, calcium chloride or calcium sulfate will form. Calcium chloride or calcium sulfate. This is the one reaction, and we have to wash in this resin. So calcium chloride was removed. And here regeneration of anion exchange resin, when react with the sodium hydroxide, in the sodium hydroxide OH molecule react with the resin and to form the ROH. This is the anion exchange resin. And the sulfate react with the sodium to form the sodium sulfate, and it was removed by the washing pure water. So these are the regenerations. And sometimes may ask you uses and advantages and disadvantages. Advantages and disadvantages. So this process can be used for the softening of highly acidic water or highly basic water. This is the more important. Acidic water can be used for the softening of this ion exchange resin or basic water. And this also produces the water very low hotness of 1 to 2 ppm, so that treated water by this method can be used in high pressure boilers. In industrial use of this water, we can use this water. And what are the disadvantages? So it is a very costly equipment. So ordinary persons cannot be used this one. It's the cost, chemicals are used, the resins are very cost. We are not able to use this one. And the water should not be turbid in this one. The turbidity level should not be more than 10 ppm. Water should not be turbid. So these are the 2 disadvantages, and write the regeneration and advantages and disadvantages in process and resins and schematic diagram. So all these things are very important for this one. So other than this, we have some other purification, the lime soda process and zeolite process. So these are not in our syllabus, only ion exchange resins are there. So thank you very much.